Hi, we are Team HSSB, a multidisciplinary seniors design team in the Kate Gleason College of Engineering. We are working with Dr. Cormier, an industrial systems engineering professor here at RIT. We need to solve the problem of getting rapid and clean full body scans of students for the class ISE 743 personalized 3D printing. Current methods are either too slow or too pricey. The goal of this project is to create an easy to set up structure that can quickly scan a student and be stored when not in use.
The vision for this project is a booth that is fully functional in capturing images of a subject automatically and setting those images to a photogrammetry software that stitches the photos together and creates a 3D model. The structure should also collapse into a small footprint when not in use. A successful result captures all of these needs while being cost-effective when compared to commercial options.
Our proposed solution is a booth similar to commercial ones. The booth will have 4 sets of cameras at varied heights on a vertical pole that captures the entire height of the user. These cameras would be controlled by a Raspberry Pi microcontroller. Each pole would also have a strip of light to remove any shadows. This setup would be repeated 10 times in a decagon shape to fully capture the subject. These vertical poles will be supported by a thick base with inserts. The poles and base will be detachable and foldable to allow for simple, compact storage.
Our team is expected to have this structure and camera capture systems complete. We are expected to integrate the two to create a fully functioning prototype for the client by the end of the semester.
One of the biggest issues that the group experienced during this project was the Raspberry Pis for the camera system. Originally, we planned to have one Raspberry Pi connect to 4 cameras with the help of a multiplexer. However, during testing, the cameras in the multiplexer weren't actually compatible despite the documentation. After several weeks of troubleshooting with tech support, we ultimately abandoned the multiplexers and switched to one Raspberry Pi per camera. This significantly increased the amount of wiring required as it quadrupled the amount of Pis that needed power, but since the Pi was much smaller, this allowed for a thinner pole to be implemented, which significantly reduced the overall weight of the structure.
We want to thank our client, Dr. Cormier, for his time and sponsorship of this project. We also want to thank Dr. Macaulay for her guidance and support throughout our time. Finally, we want to thank Dr. DeBertolo, Gary Hudanis, and the MSD faculty and team for all their assistance and technical guidance. Thank you.